It tells us that Dan hires Amy for 1 year, and then it gives us some different payoffs, whether Amy works or shirks, and whether Dan punishes or not. The question says, what is the subgame perfect Nash equilibrium of this game if it is played once, there is complete information, and everyone is rational? So when looking for the subgame perfect, we want to draw our decision tree. Whoever we list first, well, that's important. It's the person who's making the first decision. So in this case, Dan can't decide to punish Amy or not until he's seen if Amy's worked or shirked. So Amy is acting first. She's either working or shirking. So we want to list Amy first, list her actions of shirking or working. Then we get to Dan. Well, if Amy shirks, Dan has the option to either punish her or not. So when Amy shirks and Dan punishes, Dan makes 50, Amy makes negative 150. And when Amy shirks and Dan doesn't punish or not punish, Dan makes 100 and Amy makes 250. So when we're finding the subgame perfect Nash equilibrium, we're using something called backwards deduction, which means that Amy is thinking about the end of the game and seeing what will happen and making her decision and maximizing from there on. So basically she's saying, if I were to shirk, what would Dan do? Well, she sees that Dan would choose 100 over 50. So we can cross this leg of the tree out because it's not going to ever happen in a one-shot game. Amy knows that. Amy knows Dan is rational and he's going to choose $100 over 50 if this game is played once. So when we look at the other payment options, if Amy works and if Amy works, Dan will never punish her, so Dan will make 450 and Amy will make 150. So really this game boils down to Amy choosing between 250 or 150. Amy's not ever really looking at the negative 150 because we've crossed that leg of the tree out. And we know that Amy's going to choose 250 over 150. So this is our subgame perfect Nash equilibrium where Amy shirks and Dan does not punish. The next question says, suppose that Dan will have to hire a manager every year and there is some chance that Dan is the kind of manager or the kind of owner who will always punish a shirking manager, no matter what. What is the minimum probability with which Amy might think Dan will punish her for shirking to induce her to work hard? So first, we notice that it's asking about a probability that Dan will punish, which means we're going to start with Amy. And it says anyway, to induce her to work hard, so we're going to set shirking equal to working hard. So again, we start with Amy. She could either shirk or she can work. When she shirks, well, H is that probability that Dan will punish her. So if she shirked, H, she's going to get negative 150. When the state of nature H happens, she'll get negative 150. 1 minus H is when he doesn't punish her, so she'll get 250 if she shirked. Well, if she works, we know she's going to make 150 for sure. We can set these two things equal to solve for H. From here, it's just algebra, and we work through and we see that H is 0.25. So this is an indifference point again. If H was anything greater than 0.25, Amy will work for sure. If H is anything less than 0.25, Amy will shirk for sure. It's when H is equal to 0.25, she's indifferent between working and shirking. And this is our answer.